Hello Internet and welcome to this quick video on electrolysis, perfect for GCSE science. It should be noted that this is quite a difficult topic, so if you do need to rewatch this video a few times, please feel free. Let's start by defining what electrolysis is. Now, electrolysis is the splitting up with electricity. For GCSE, a substance is generally returned to its elemental forms. Now, let's start by labelling this diagram in a bit more depth. First of all, we can say that the liquid is an electrolyte, which is a molten or dissolved compound that an electrical current is passed through. We know that an ionic solid cannot be electrolyzed, as the ions are not free to move. However, when it is molten or dissolved, these ions can move freely and then conduct electricity. This is vital for electrolysis. Next up, we'll label the cathode, which is on the left-hand side of this diagram. Now, we can say that the positive ions, known as the cations, in the electrolyte move towards this negative electrode, the cathode, as opposite charges will attract. Here, they gain electrons, meaning they are reduced. On our other side, we have the negative ions, known as the anions, in the electrolyte, moving towards the positive electrode, the anode. Again, opposite charges attract, but this time they are going to lose electrons, meaning they become oxidized. Now, as ions gain or lose electrons, they are going to form uncharged elements and are then discharged from the electrolyte. It should be noted that the electrodes should be inert so that they don't react with the electrolyte. Moving on to an example. Now, electrolysis is generally used to extract metals from their ores. For example, aluminium could be extracted from its ore, bauxite, which is the example we'll look at for GCSE. Now, it is generally used when a metal is more reactive than carbon. If a metal is less reactive than carbon, then mixing the carbon and the metal ore will allow the carbon to displace the metal, which is far cheaper and much more energy efficient than using electrolysis. However, if this can't be done, then electrolysis must be used. So, bauxite contains aluminium oxide, which is Al2O3. It's important that you remember this. We can say that aluminium has a very high melting point, so it is mixed with cryolite to lower this. And also we can add that the molten mixture will contain free ions, so will conduct electricity, which, as you know, is vital for electrolysis. Now, labelling our left-hand side here, we have the positive Al3 plus ions attracted to the cathode, our negative electrode, where they will each pick up 3 electrons and become neutral aluminium atoms. These will then sink to the bottom. Once again, they are gaining electrons, so are reduced. And we can say that Al3 plus 3E minus, E minus is used to represent electrons, goes to Al, which is just aluminium in its elemental form. Pretty simple. On our other side, we have the negative O2 minus ions being attracted to the anode, which is our positive electrode, where they will each lose 2 electrons. The neutral oxygen atoms combine to form O2 molecules. Oxygen is diatomic, meaning it will always form a covalent bond with another molecule of itself, hence O2. Here we see that they are losing electrons, hence being oxidized. You will notice that the amount of electrons they gain or lose are the amount they have over their elemental form. So for instance, Al3 plus, it will pick up 3 electrons so that it loses the 3 positive charges. As electrons are negatively charged, it needs to lose its positive charge. To do this, it gains that negative charge from the electrons. Similarly, on the other side, we have O2 minus. Here we have 2 negative charges, so it will simply lose these 2 negative charges by giving up those 2 electrons. On that right hand side, we can say that 2O2 minus can go to O2 plus 4E minus. This looks a bit more complex, but think of it like this. You have O2 minus and then you are taking away the electrons, and when you're taking them away, we're simply adding them on the other side of the equation. And obviously we have 2 O2 minus and we have 4 electrons here, as oxygen forms diatomically, therefore we need to double the amount on one side and balance our equation. This will give us an overall equation of 2Al2O3 as a liquid going to 4Al as a liquid plus 3O2 as a gas. A final thing to note is that the anode is generally made from carbon here, so it will react with the oxygen. We obviously don't need the oxygen, so this doesn't matter much. However, it does mean that the anode will need to be replaced